Hi, everyone. My name is Chirag Dill. I run Senior Product Marketing Manager for Amazon Managed Blockchain at AWS. And this is the AWS office hour for Amazon Managed Blockchain. I wanted to invite and introduce some of our guests here today. We have Jonathan Fritz, who is the head of Amazon Managed Blockchain product and engineering team. John, why don't you introduce yourself?
Thanks, Chirag. My name's John. Thanks for coming to our office hours. I guess I don't have much more to add. I run product and engineering for Amazon Managed Blockchain.
Fantastic. Thanks for joining us here today. And we also have some folks from our distributed team who are joining us today. We have Shruti Rao, and Shruti is popping up on your screen now. Shruti, please introduce yourself.
Hey guys, I'm Shruti Rao. I head business development for Amazon Managed Blockchain, and I'm excited to be with you guys.
Awesome. And we also have Jonathan Shapiro-Ward, who is joining us from New York. Hey, Jonathan.
Hi there. My name is Jonathan Shapiro-Ward. I'm an AWS Solutions Architect, so I work directly with our customers to help them be successful in AWS.
Fantastic. Jonathan, thank you for joining us. Okay, so why don't we get things started? I have a couple of housekeeping items for us before we can jump into the questions. So as you all know, office hours is a new concept. So we really wanted to kind of first figure out what office hours really mean and how this really works. So I actually searched the internet and came up with some definitions that I found interesting for what an office hour is. The time during the day when people work in an office, I think that's kind of true.
Yeah.
And maybe if we had offices like this, that'll be wonderful. The time during the day when a teacher is available to meet students, or when people see a doctor or dentist. Well, we're not doctor, dentists, or teachers, so not sure how relevant those definitions are for us. So we actually came up with our own definition. How is this office hour going to work? So thank you, everyone. You asked a lot of intelligent, smart, and wonderful questions about blockchain, Amazon Managed Blockchain, and how to build a solution on Managed Blockchain. So we have taken all your questions. We have now figured out various resources from our side, and we have experts here who will answer your questions. So to give you an idea, we had around 300 customers who signed up for the office hours. We got around 150 questions, and we have bucketed them into various categories. So today, during this office hour, we will go through the questions through those categories, and then we will also have time for live Q&A. So feel free to ask those questions on the chat window, and I will make sure to monitor the chat window and make sure to bring those questions up to our guests here. And also, if you just want to hang out and listen and absorb all the knowledge, feel free to. You're not pressurized to ask any questions at all as well. So we appreciate all of you joining us here today. Great. So let's get things started. One of, I think, the biggest hot topics, one question that we get a lot actually is, what is blockchain and do I even need a blockchain? So I would like to start that question and pose it to John. John, what do you think and what is the perspective? Can you share a little bit more on that?
Yeah, sure. Thanks for everybody for joining the webinar. Feel free to ask some questions and we'll, I guess, take them as they come as well. So, this is a pretty meaty topic, and when we go out and talk with customers about blockchain and more importantly, the kind of use cases and problems they're trying to solve, there is a lot of nuance on, exactly, do you need a centralized system or a decentralized system, and kind of all about that. So I guess I can try and answer this a little bit maybe on actually kind of the easiest way is almost how we arrived at launching these services. Kind of talks a little bit about what blockchain is and like why do people need it? How are customers using it? And we got I think we put a couple slides in here that might help visual aid.
Sure, feel free to take over.
So this kind of helps because to really think about, do you need a blockchain, you kind of have to understand like the yin and the yang, like centralized databases versus when you need a decentralized blockchain. And so, when, I guess the easiest way to think about it is when we're out talking with customers, actually this is even going back before we launched these two services, we found that a lot of customers obviously came to us and said, we really want to run blockchain. And they kept talking about that as this technology solution. AWS, we don't really recommend technology because we think it's cool or there's hype around it. It's really all about working backwards from what a customer needs and solving that use case. So we asked, what are you trying to do? You're saying you want blockchain, but tell us your use case. What we found was that there's really two buckets of use cases, and you kind of need to describe both to really paint the full picture. And the question of do you need a blockchain or not? So for the first bucket of use cases that we saw, some customers who came and said they want blockchain ended up in a place where actually they didn't really need a blockchain. And this is the slide I'm showing right now. They really had the centralized use case. These customers were running centralized systems, like say a database, right? But they had a use case where they wanted to make sure that all of the transactions that were put in that database, all of the state changes, were immutable. Oftentimes it's because they were getting audited, right? So an auditor comes, they say, are you sure nobody's tampered with anything? And then they have to spend a lot of effort in proving, that audit process. And they could use things like audit tables in the database. They could use there's obviously a variety of ways you can go about doing it, but it's pretty cumbersome to do that, right? The databases don't have this immutable log built in. So these customers would arrive then at blockchain. They'd say, well, blockchain isn't a database. It has a variety of things that, it can do. It's decentralized. It runs smart contracts and not SQL queries directly and things like that. It does all these other things, but it has this one thing we're interested in, and that is this ledger, this concept of a database that has this immutable log that's tamper-proof. And so these customers would end up trying to use blockchain, but really they didn't want blockchain. They just wanted this small part that's almost like the kind of journal part of the database. So these folks then would kind of enter in this world, and they'd get a lot of problems because blockchain doesn't perform the same as the database systems they're used to. It's more complex and that sort of thing. So these customers, we ended up launching a service for them called Amazon QLDB. And this service is now in preview. And QLDB, Quantum Ledger Database, is a purpose-built ledger database. And so for some customers, kind of going back to the initial question, these guys don't need a blockchain. They need a centralized ledger database that can keep track of all the transactions that happen in an immutable way, but isn't a decentralized system. It's a database. You can run SQL-like queries on it and plug it more into your system in a way that you had your database before. But that tells only the first part of the story. And so kind of going back to the question of how do we think about blockchain and do you need one? And this is kind of where that real differentiation comes from, is that the second set of bucket of customers that we talked to that came to us and said they needed blockchain actually had a very, very different use case. And these use cases were all around decentralized systems, that it typically wasn't, hey, I'm a customer and I have a database that I want to replace. It's, I'm a customer, I've got other groups that I want to go interact with, but we can't really figure out an elegant way to do it. Either we have a central authority that we all have to transact with, and that person will then transact with the person I really wanted to talk with, or no one can really decide how the infrastructure gets set up, or everybody has their own data silo, and you have to do a lot of reconciliation between all these different things, and that makes it difficult to understand. And so we saw, these are some of these examples, right? Like, consortium wants to get together to work together, but no one can decide who owns a database. They might try and create a joint venture to own all the IT, and that kind of gets clunky. So anyway, so these are, I won't go through all these, but these are kind of examples of any centralized system, whether it's a ledger database, a NoSQL database, a MySQL database. The problem is just a centralized system isn't going to address this well. And so that's kind of where, we think about blockchain or, customers, when do you need one, is that it builds trust in a network to where you had something on the left where you have everybody interacting with a central point to now it's decentralized, everyone's on the same page, and there's no need for a central authority or kind of these other more clunky architectures. And so when you think about, do you need a blockchain or not, it's really around, or do you have a use case that you're interacting with other organizations in a way that you want to have these transactions be efficient, and having everybody own a piece of that network versus me having a database and exposing it to all of you like a SaaS solution. So I'd say that's also when we say blockchain, we don't mean ledger, we don't mean consensus. We say blockchain technologies at AWS, we're actually referring to like a layer cake of technologies. The base level is that distributed ledger, but every participant owns a full copy of that ledger. On top of that is the consensus mechanism that kind of decides what's the state of the network, what gets written to that ledger that everybody owns. And then on top of that is smart contracts. So the interface between blockchain is a smart contract, not like a database where it's just database type operations. You can do that through a smart contract, but you can also do a variety of arbitrary code execution.
Got it. That's very fascinating. And Shruti and Jonathan, feel free to jump in if you have any other thoughts as well. But one thing I'm kind of deriving from this is that the role of an intermediary, like the diagram that you were showing on the right, which had a bunch of decentralized distributed nodes interoperating with each other.
Yeah.
There was no central authority at that point. So I assume that a lot of businesses who are running in that way, where they have multiple entities and are trying to derive some efficiencies, they would definitely benefit from that.
Yeah, I mean, I think what we see today is having, obviously like some of these networks exist today with central authorities. So it's like, banking systems exist today. It's not like you fundamentally can't do some of these things without blockchain. But what blockchain enables you to do is remove that central authority. And what happens there oftentimes is it's less expensive because a central authority will take a cut, right? It needs to be able to fund itself. And also, it's relatively slow, that for things to clear, oftentimes these central authorities, you measure that in days versus, why can't a transaction between two separate parties happen atomically and quickly? So, what we're seeing is customers experimenting and building these architectures to try and drive efficiency and transparency into these systems, where you reduce the latency of the end-to-end clearing process. And also, it's more trackable, that you can go back and everybody who's part of that transaction can independently verify what happened versus me calling you in a supply chain and figuring out what happened, or having to spend a lot of time reconciling whatever event happened. And, by events, there's thousands of these happening a second. So, there's a lot of transactions going on that you would need to track.
Makes sense. And to kind of compare it to what kind of technology people would use today, it would be something like API integrations. And obviously that has some sort of its own challenges as well, where multiple systems have to interact and rely on each other for some of these kind of syncing each other's data.
Yeah, I mean, I think we'll talk a little bit more about this in some of the use case questions that come up later. But I think that's totally true, that there's something about blockchain that also we found a benefit of is you're getting groups of customers together. And if every customer has their own siloed system, one thing that typically comes with that is different APIs, different stack. And you get this kind of weird mishmash of trying to integrate all these systems together that becomes almost like tribal knowledge across n number of participants. So if you think of like the n cross n combinatorial pattern, anytime you add a new person in, a new organization in with their new stuff, you kind of make that really expand the scope and of what you need to cover, and it just gets hard to maintain. So what we found is that people who are porting this over to blockchain, there's now one standard. It's the API interface for like Hyperledger Fabric, and everyone is standardizing on the same thing. And that just makes it much quicker to develop, add new participants in, and maintain the system.
Right. Makes sense. Cool. So,
I want to jump in really quickly and elaborate on something that John was saying about central trusted authorities who manage, before the advent of blockchains, managed it. When we think of central trusted authorities or parties, we think of someone external managing between our customers or a consortium of various members. Also think of a supply chain use case where, let's say, a fast food company is working with let's say, spinach producers, distributors, trucking companies, distribution centers, and then the fast food, let's say the fast food joins themselves. Now, the fast food company becomes the central trusted authority. Now, they have the responsibility of making sure that the spinach was harvested by the farmer and actually got on the truck. It's an undue burden without having to really evaluate whether or not the spinach indeed got on top of that truck. So there is a lot to be evaluated in near real-time basis by this fast food company. Fast food is just an example. You could replace fast food with anything else, and they become the third party, which is both being one of the members and also the validator of this network. So using some kind of a distributed ledger technology such as blockchain eliminates that need for this fast food company to do both, be the beneficiary of this and be a third party within this ecosystem. So that's one of the few ways our customers are thinking about how can we really use blockchain when it's not a consortium of equal peers needing a third party that's outside of their ecosystem. It's also when can I eliminate myself as a third party and actually just do fast food.
Got it.
Actually, Tara.
Got it. Thanks, Shruti. And I think we'll come back to that example. That's pretty interesting in later part of our discussion. So one kind of topic I want to bring up now was tell us a little bit more about the kind of offerings and services that AWS provides. So we announced the Amazon Managed Blockchain Service preview at reInvent and then GA a couple of weeks back. So as you're very close to that, can you tell us a little bit more about that?
Sure, yeah. I mean, I can talk about, I guess, both of the offerings we have in the blockchain category. We'll start with Amazon Managed Blockchain. And yeah, we're super excited. The service actually launched in preview at AWS reInvent. And for those of you who don't know, AWS reInvent is our big developers conference in Las Vegas that happens every late November, early December. And so we're super excited to launch the preview then. And the service was in preview until about a month ago. Then it was released generally available. So right now, the Amazon Managed Blockchain is available. You can go to the console, in a couple clicks, launch the network. And the goal of the service is to make it easy for customers to build blockchain networks across different AWS accounts. Obviously, one of the core tenets of blockchain is that you're going to want to have multiple different members that are each owned by different organizations as part of that network to maintain it. And so the goal of service is that, and we're using open source technologies as well. Right now we have Hyperledger Fabric available in the service, and there's a bunch of questions I think coming up on exactly some of the nuances of that, and so we'll get into the details. But Fabric, kind of at a high level, it's a great enterprise blockchain platform. It's got a lot of features that you'd expect out of an enterprise solution, and also just generally lends itself well to how you'd architect these use cases. Also, we as an option have Ethereum, and that's coming soon. In Ethereum, you'll have the opportunity to connect to the public mainnet, but also create private Ethereum networks as well. And that kind of interfaces that you'd write smart contracts with are different. There's a couple differences as well. So we're excited to support that, and that's coming soon. So from a blockchain standpoint, Managed Blockchain is there and it's available for use. From the Ledger database point of view, we've also got QLDB. That's still in preview. That was also announced at reInvent last year, and that kind of addresses that first use case I was talking about, where you want a ledger database. You want to have this immutable aspect to the centralized system that you are running, and QLDB is a great choice for that. And you can sign up on the preview page, and there's also more information, I believe, on the website about it.
Sounds great. And then coming back to Amazon Managed Blockchain, this question came up quite a lot in our Q&A. Is what is Amazon Managed Blockchain? How is it different from, let's say, running my own Hyperledger Fabric? Can you first tell us a little bit few of the benefits of Managed Blockchain service, and then go deeper into how is it differentiated from running your own Hyperledger Fabric network?
Sure. There's a slide. So I mean, I can. There's a bunch of different ways to go in. I can talk about, I guess, some of the benefits. But first, when you're building a Hyperledger Fabric network and you want to actually run it seriously, there's a bunch of different components. I mean, the service is in and of itself pretty complicated. If anybody who's on this webinar has set it up themselves, kind of all the different components that need to be working. But the components aren't just like, hey, I spun up a Docker container with X service in it. If you're running in production, you need to make sure that it's highly available, that you've got all the right security controls in place. And I'll give you some examples. Like if you run Fabric yourself, you will need to have an ordering service, and that's the thing that takes in all of the endorsed transactions, batches them up into blocks, and then spits them out. So very, very critical piece. If you want to run it in production and with open source, you're going to have to run a highly available Apache Kafka cluster to back the ordering service. And also that Kafka cluster, this is blockchain, so things are going to scale and add more data to this indefinitely, because you want to have the transaction log all the way back to the first Genesis block. So you've got to now scale Kafka. You've got to run it in multiple availability zones if you're thinking about it from an AWS perspective. And that's just like one small component of your whole thing. But that in and of itself, managing Kafka is difficult. We have a managed Kafka service, but still, that's one component that you have to worry about. For security, each organization in Hyperledger Fabric is defined by a root certificate that's like the calling card for that organization. So all the users and identities from a specific member, I use kind of member and organization interchangeably, but everything from that stems out of that root CA and has that train of trust down to the root CA. Well, how are you securing it? Well, if you're running open source, you need to buy an HSM and store it in there. Okay, well, that's expensive and complicated to do. For networking, you want to add in 10 members to your network. Well, I mean, you probably don't want to expose everything to the internet so no one DDoSes your order, right? And so how do you deal with all the complicated VPN and networking if you're setting up yourself? So those are just a few of a laundry list of things where if you want to run this in production, you've got to take care of a lot of stuff. And so I'd say that one of the main benefits from managed blockchain is that all the things I've described, we take care of for you. You can go into the AWS console, you can click a couple buttons, and within 20 minutes, you've got a production grade network ready for you to use. And it's to add more accounts. We'll talk a little bit about voting in a minute, but to add more accounts, you click a bunch of buttons and all the networking and all that stuff is taken care of as well. And so we kind of scaling it back, we, for each organization, secure the root CA with HSM grade technology using AWS KMS. The ordering service for the network, we actually don't use Kafka. We use a internal proprietary technology that is the same journal technology that backs the QLDB journal. We also use it internally in a few other places as well. And this thing is more durable and reliable, we believe, than utilizing Kafka for the order. Because if you think about it, the ordering service holds a lineage of all the transactions forever. Kafka is more built as a stream processing, or not stream processing, but a streaming storage engine where you have some duration of window and things are going through versus storing everything in some sort of HDFS like storage system you might store on those Kafka nodes. So we believe it's a better fit. Our peer nodes, the storage scale. So we've built the service in a way where we manage a lot of the complexity and the ability to scale it out and the security. Like when we expose these endpoints that I keep talking about, like on the Fabric peer of the order, we expose them through VPC. So it's not going over the internet and it's directly interacting with clients you might be running in your VPC. I think there's some more questions on networking later, but a lot of that stuff, we take care of. We'll have a variety of frameworks. Right now, we only have Fabric, but Ethereum is coming soon. And when we have both, it'll give developers the ability to choose what smart contract languages they want to use. There's a bunch of different features from each framework, so there's some choice there. It'll be integrated with other AWS services to move events out into other storage systems, and QLDB is available. There'll be that integration. And then finally, it's built in a decentralized fashion. So it's kind of an interesting point. I think it'll come up again later in some of the questions, but it's different than your typical cloud service. Like if you have an S3 bucket, let's say, like I create an S3 bucket, I might allow you to upload things to that bucket, download things from the bucket. So it's kind of shared, but I can revoke your privileges, or I could delete my AWS account and all of that stuff is gone. And imagine that was like a mission critical thing for you. You're basically giving me the power to totally disrupt your business. A lot of customers are coming to blockchain because they don't want to give a central authority that's not them that sort of power. But if the system was built in a way where if I create a network, I invite all of you to join, and then when I leave, let's say I do something bad and you guys want to kick me out, if the network would then collapse from that, then that would kind of ruin the purpose. And so managed blockchain is built actually where I can create a network, invite all of you, and there's voting rules where the network, based on those voting rules, can vote on what accounts to add and also who to remove. And if the person who created it is, say, removed, or they decide to leave, the network is just fine, that there's no real owner for the network, that you could say everyone owns the network or nobody owns the network. So that's kind of another interesting attribute. So all those things together, the idea is, we want to take away the undifferentiated heavy lifting of running this stuff so customers can worry about writing their applications and bringing the nuances of their business use case to their application portfolio versus worrying about running an ordering service or configuring HSMs, all these things that are expensive and take time. So I'd say that's high-level view on, I guess, the value that we hope we can bring to customers.
Something that I'd like to add there is that I work with a lot of customers who are interested in employing blockchain in various aspects, but they aren't necessarily experts. They don't necessarily have the engineering staff and the resources to do an extensive POC, less actually then productionizing it afterwards. And when you've got companies who are trying to be innovative, who are trying to explore new technology, really having this heavy lifting to do before they can get any value really diminishes the returns that they can get. So one of the key values that I see for the customers that I'm working with Amazon Managed Blockchain is that acceleration, that they can fail faster, they can explore new technology without having to have such upfront investment. I've seen POCs done on premise or even just on EC2 instances take months to do. That's no longer the case.
That sounds great. Thank you, Jonathan. Great. So thank you for that quick overview about the service, and I'm sure we'll go deeper into the various aspects, architecture, etc. Yeah. But at a high level, like how does it all work? How does it all come together? Can you give us like a quick overview? And I know you shared like a slide with me, so I'm gonna put that up. Can you just talk through us through that?
Yeah, sure. I mean, it's and now that we're GA, you can folks can go into the console and literally see this there versus having to be whitelisted for a preview or something like that. But it's pretty simple. You go to the AWS console, you can use the CLI. Obviously, everything's API driven, but console is the easiest way. You click on create a new network. You provide the name, some descriptions, a couple of other fields. And you hit create, and what will happen is the network will be created, your initial member will be created, and then you can invite other AWS accounts to create their members, or you can create multiple members in your account to simulate a multi-party network if you'd like. Oftentimes you see that in POCs where you might want to create a 3-member network to test out all your applications before then inviting other companies to go and join it. It's kind of have your test stack, like your dev versus prod stacks. Once you create a member, then you have to create your peer nodes. If you think about it in Hyperledger Fabric terms, a member is kind of equivalent to the organization stuff. So like the configurations that happen to have that organization join the network and your CA and that sort of stuff. And then once you have that up and running in our service, a couple buttons you can click, you can launch peer nodes using a variety of different EC2 instance types. So we've got T3, C5s, and M5s, depending on the performance that you need. And you can launch multiple peer nodes in different AWS availability zones for high availability purposes if you want. From an availability of the CA and the order, actually we have a question on HA later. So actually we'll leave it to later. But then you basically create your VPC endpoint and you can interact with all those services. You download the open source Fabric SDK. We didn't build like an Amazon Hyperledger Fabric SDK or something like that. We're using the open source standards, and you go download the SDK from GitHub, from the Fabric Git, and start interacting with your peer nodes. So you can get up and running with a production grade network in 30 minutes or less.
Sounds great. Thanks for that, John. And one thing is becoming more and more clear as we have spoken to a lot of customers is that our service offering is more of a technology, and it's not just some sort of a cryptocurrency offering that many customers may be getting confused with. Not sure if you have any thoughts to share. Like, according to me, cryptocurrency is just one implementation of blockchain. However, there are so many diverse use cases where they can use actually the core technology of blockchain to solve a bunch of use cases.
Cool. I mean, Shruti, you want to take this one?
Yeah. And I agree with you, Chirag. Cryptocurrency is one use case. It's more talked about use case, but not the most popular or more experimented use case, definitely. You see track and trace, whether it's, as I was talking about spinach earlier, or any of the food or physical or digital assets as one of the most common use cases that our customers are experimenting on and using blockchain technologies for. We see settlement and clearing for financial transactions, retail transactions, or also insurance type of transactions. Anytime where there are more than one party in the process of a sale of whether it's a physical or digital asset, the settlement and clearing is the use case, a very important use case that blockchain is being used for. And the third big bucket of use cases that we see is some kind of a peer-to-peer, which could be cross-border money transfer, fractionalized asset trading, trade finance, things like that, where there were multiple intermediaries, multiple parties within a value chain from the originator to the end party, and those parties can be eliminated by peer-to-peer transfer.
Awesome.
Those are the three main buckets of use cases that we're seeing, and this is across multiple industry verticals, from agriculture to healthcare, oil and gas, high tech, financial services, of course, media, entertainment, advertising, automotive. So all of these industry verticals and even government is using blockchain at a very high level in one of these three different ways.
Got it. No, that's great, and thank you for that overview. So we've kind of covered what blockchain is, what's our perspective, what are the key benefits of our service, and some of the use cases where folks can start using this for. Now, I would kind of like to dive deeper and talk a little bit about some of the deeper architecture level questions, and then I'll definitely come back to you, Shruti, on some of those use cases as well. And then finally, we'll go and talk about some of the best practices around security, high availability, and then how you can get started. So let's begin kind of the second phase of our questions. Now, going into the kind of the architecture questions, we got a ton of questions that the audience asked. And let me start with the first one, which is now unpeel the onion a little bit about architecture of Hyperledger Fabric Network, and tell us a little bit more about transactions. How do they even get committed, etc. on it?
Yeah, Jonathan, do you want to take this one, and I can chime in too?
Sure. Actually, I'll let you lead with that. My audio is cutting out a little bit. So
no worries. I've got kind of I wish I brought a slide on, or did I put a slide in there on this?
I think so. You sent something over to me. Let me quickly, is that?
Whoa, that font is looking crazy. I'll just talk through it. That's fine. So, the way I kind of think about the architecture of Hyperledger Fabric, you kind of got the different services that are running. So like what services are running across the multiple organizations that are in a network. And then thinking about how do you overlay that with, when I want to do a transaction, what is the flow that happens for that transaction? And then you kind of like put them together, and then you get a view of how the full system works when it's operating, and then you scale it up to thousands of transactions per second. So I guess let's start with kind of how Fabric works. So Fabric as a network has got a few different components. So for each member, Fabric network is basically a groups of members, and then this ordering service that's kind of a shared asset for the network. So each member has what's called a Fabric Certificate Authority, and that is that thing I referred to earlier that has the root CA that's like the identifier for the network, that all the users or all the identities that are part of that organization, part of the organization, the chain of trust boils down to that root CA. So if you and I were different organizations, we'd each have a different root CA, and somebody could identify that I'm part of org A and you're part of org B, and not vice versa. So when we're on the network transacting or interacting, you can't pretend that you're part of a different organization. That's kind of the chain of trust, so to speak. So each member has their own root CA. They also have their own peer nodes. Now what a peer node does in Fabric is it does actually a couple of things. One is it stores a copy of a ledger. So each peer node stores a copy of the ledger. And we say ledger, that's the journal, which is that immutable set of transaction history that, forever. That's like kind of the blockchain part of the blockchain. The ledger database also has this thing called the global state DB, and that's what you're querying. It's kind of like when you think about your bank account. You might have debits and credits, but when you go to the ATM, you're looking at what's the balance. The global state is the balance. The journal is all of those things that have happened. Both of those together equal ledger. So peer has a ledger. The peer also is the thing that endorses a transaction. We'll talk about transactions in a second, but it's simulating transactions that are proposed on the network and deciding, is this good or is this bad? So peer does that. and that's kind of the way the network builds consensus. So those are the two main things that the peer does. So each member has those things. So if you have 10 members, you'll have 10 CAs and 10 or more peer nodes. Each one is one. And then all of the members interact with this ordering service. And the ordering service then takes in transactions, makes sure that the endorsement policy is okay, and then make sure that transactions are ordered correctly into blocks, and then sends the blocks back out to each member. So that's kind of a high-level view of the different services that are part of a Fabric network at a very high level. Now, how does a transaction get committed? Another good question. So the first step is that there's a client to the network. And that's in the managed blockchain sense. That's like I'm running an EC2 instance in my VPC that's running the open source Hyperledger Fabric CLI. And so and there's some smart contract chain code that I've installed on the network that I want to go interact with. And so that client will propose a transaction. And depending on the endorsement policy of the network, which is how many different organizations need to give a thumbs up for that transaction, the client will basically send the proposal transaction to all the organizations in the network through that VPC endpoint. Each member's peers will validate the transaction, and assuming it looks good, will send back a signed version of that. It's a read-write set saying, yeah, this looks good, we sign off on it. That client is collecting all of those endorsements from all the different organizations, and then when it meets that threshold, we'll send that package of signed endorsements to the ordering service. The ordering service will check and make sure it's okay, and then commit the transaction to a block, send the block out then to all the peers, and then the peers then do one more validation, because that cycle time isn't atomic, right? There's a lot of things moving back and forth over the wire, and so in that split instance, something might have changed where that transaction would become invalid. So the peers do this final validation check, and then if the peer says, okay, this is valid, if all the peers say it's valid, it actually gets added to every peer's ledger and becomes a transaction that is a valid transaction on the network. So that's kind of the flow, is from client to peers, back to client, to the ordering service, to the peers. And that, depending on the speed of the kind of volume of transaction in the network, could be happening, thousands of times a second with a lot of moving around. So there's a bunch of moving parts, and that's kind of goes back to the original, what's the value of the service, is that we kind of handle a lot of that where you don't have to worry about the peers and the orderer and all these things. You just write the applications you want and start transacting on the network.
Got it. Cool.
I think to jump in there, I think something that is worth mentioning is that for those who aren't familiar with Hyperledger, you're not hearing things like proof of work or proof of stake, for example, which are terms that get commonly branded about with other blockchain implementations. But the difference is that there is no cryptocurrency built into Hyperledger. There is no element of mining, for example, or doing a proof of work. So it's a very different architecture. It embodies many of the same concepts around, for example, the ordering of transactions with a block and the hashing that goes on. Much of the same things are there, but it's a little bit different to wrap your mind around. So if you're coming from a different part of the blockchain community, it's a little bit of a different thought process, but it has some slight advantages, and it has a lot of features that might be more valuable for the enterprise.
Yeah, I mean, to build on that, that's a great point. One of the benefits is that your transactions per second are much higher because you're not doing a proof of work type consensus building. And also, people are joining these Fabric networks. Obviously the public networks, the incentive to maintain a node is to try and mine blocks and get cryptocurrency, which is a value. In these permission networks, it's a business value that's driving it. That if you could say you can make a supply chain 10% more efficient, 20% more efficient, that's huge savings for a business, and that more than makes up for the kind of cost of running it. So it's definitely a different mindset, and solves a different set of problems as well.
Got it. And can we come back to that point of proof of stake and proof of work? And one could think of Ethereum being the other framework that leverages that. So I'm sure there are different kind of business needs for that as well. And I'll probably come back later on that and talk a little bit more. Now, talking about writing applications, like questions around chain code came up quite frequently. So just tell us, what is chain code, and how do you get started? If I'm writing existing chain code on my Hyperledger Fabric today, how do I bring it to managed blockchain?
John, you want me to take that, or do you want to take a first crack? I can start.
I can take that if you guys can hear. Hey. Sorry, my client's freezing a little bit.
Yeah.
The problem with that then, that if you got existing chain code, it shouldn't be much of a difficulty to actually port that. So I've done this quite a few times with chain code that I've written, on a containerized deployment on my laptop, or Hyperledger. By and large, the experience is still the same as open source Hyperledger. It's the same interfaces, the same APIs, the same tooling. So migrating and moving chain code between on-premise environment or an EC2 instance deployment of Hyperledger Fabric and the Amazon Managed Blockchain service shouldn't be much of a challenge at all. I've done it successfully quite a few times.
I think I want to add a couple of things. I think because of the open source parity, we have seen migrations be pretty easy. If you are writing in Node, because there's a bunch of different languages you can write chain code in. There's Go, Java, and Node.js. If you're writing in Node, we do include the Fabric shim packages on there, which are required for Node. But in some cases, you might want to package your own libraries along with it. We don't give you root access to the nodes, which is good by design. But you'll have to package using some utilities your extra node libraries with your application. So that's one thing that we've been helping customers with if you happen to use Node, because the packaging system is different. And then from a deployment standpoint, we expose the pure endpoint via VPC, and so you can there's a variety of different ways as long as you can interact with that endpoint. That's where your client might live. So obviously, we have a CloudFormation template in the AWS labs that spins up an EC2 instance, downloads all the dependencies in the client, and gives you a client node. But you can also use things like Lambda to go interact with the VPC endpoint, or if you direct connect into your VPC, you can have whatever's running on the other side of that direct connect interact. So as long as you can resolve the VPC endpoint from wherever that client is, you're good to go from a deployment standpoint. And we'll be releasing more blog posts over time on just interesting ways to embed these sorts of stuff in your application. So, and if anybody has any interesting stories to share, definitely drop us a note. We'd love to learn about how you guys are interacting with the service.
Awesome. And I was talking about blog posts. I did sneak in a link to the to one of the blog posts about how to write the non-profit application using chain code. So we'll talk about that.
One more thing. This question came up. I think we actually have it in our later in a later slide, but somebody asked it now. I feel like it might be
go for it.
Somebody asked, can managed blockchain be used along with Hyperledger Composer? And so for those of you who are not familiar with Composer, Composer is a project that kind of gives a little bit of a UI and a higher level abstraction over kind of organizing a business network and writing chain code applications that can interact across the definition of that network. Also, it's noted that project is now kind of end of life, that the Hyperledger Foundation has decided that there's really going to be no more active development on that. A lot of those concepts are going to be actually put back into the core projects directly. And so the answer is, can you use that with managed blockchain? So we haven't tested it yet. The APIs are open, so conceivably it works. Like, we know you can use Hyperledger Explorer with the service. We do plan on seeing and running some tests to see if you can use it. But we right now it's not supported. It might work, but we are not exactly sure yet.
Got it. Great. And folks, again, feel free to keep adding questions through the Q&A, and thanks to those of you who have added the questions. We are definitely going to address as much as we can. Okay, moving on. So now coming to the topic of access control and identity management. I know in the beginning you touched a little bit about person A starting up a network and adding members.
Yeah.
So tell us a little bit more about how do different members get added to the same account? How does access control and identity management work?
Yeah, I can dive into that, and if anybody else on the line wants to jump into, let me know. But I'll kick it off. So, it's kind of like in the normal AWS database service world, there's kind of two different levels of user management authentication to think about. One is at the service level, and one is at kind of the core engine level, in this case, these open source frameworks that are running. So we'll kind of start at the service level. Service level uses AWS IAM, Identity and Access Management, users, roles, etc., to interact with our APIs to create a network, call a vote to add a member, create a resource, delete a resource. It's all using IAM credentials, and you federate in, if you had an Active Directory, federate in with an IAM role, create an IAM user, kind of the general pattern that you'd use with other AWS services, you'd use with us as well. And same thing when you're voting on a proposal. Let's say we're in a network and we vote to add in a new AWS account, you'd be using your IAM credentials for that account to go do those sorts of activities. So that's all through IAM. From a Fabric perspective, when you create a member, remember you get that root CA, and then when you create a member, you also create your admin user, your first admin user. And that admin user is username and password that lives in the data plane, basically in that network. So that's a different user than your IAM user. With that user, you can create additional identities for your organization, whether it's other users or maybe you have some sort of application that needs an identity. But basically all the identities that you'll need. And the way that works with Fabric is that you create a user that has a username and password, and then you enroll with the CA to get back a certificate, a public-private key. And then that's how you actually interact with smart contracts that are deployed on the network. So your password, you only really use to retrieve that, certificates. And then that's what you're using with your application. Like when you configure your Fabric CLI, you're configuring it with your certificates that define what user identity you are. And so that's a separate set of users than IAM. So that's kind of how authentication and authorization work with the service. Authorization being also like in Fabric, you can say this user can do X, Y, and Z. This user can't. And then from a channel perspective, we haven't really talked about channels that much, but a channel is like in a network, you can have multiple channels. Each channel is like its own blockchain. And so think of it like a subledger or each specific ledger that makes up the network. Yeah, this is actually a slide. Nails that definition, and then different users can have different read or write or no access over a channel.
That sounds great. Now I've kind of wanted to move on to the next set of questions, and also want to do a time check. We're around 12 minutes away, so I definitely want to prioritize some questions here for our audience. Now, in terms of just one thing I wanted to kind of catch us up on, as you mentioned the CLI, so I want to kind of dive deeper on what are the different ways how developers can interact. It's the CLI, we have an SDK. Can you tell us a little bit more what Hyperledger Fabric offers?
Yeah, I mean, Fabric, we're running the open source Fabric 1.2 right now, and there's on the Fabric GitHub, a CLI and SDK that you can download, and a variety of different languages are supported. And that's how you would, kind of create users, submit transactions, deploy, instantiate chain code using that. For AWS APIs, which is like the service APIs, so creating a network, we've got, the AWS CLI, AWS SDK in the console. So variety of different ways you can interact with the service.
Got it. Perfect. No, that sounds great. And then now moving on, security. I think security has come up a bunch of times. Jonathan, I want to get your take on security. I know you build a lot of security, secure applications, leveraging the whole AWS stack. Work a lot with customers. Can you kind of educate us on that a little bit?
Absolutely. John there mentioned the authentication and authorization aspects, but there's also other security aspects of Amazon Managed Blockchain. So there's certainly the encryption at rest and the encryption in transit that provides secure communication and storage. But there's another portion that I think is particularly relevant, which is regards to the network layer, that there is a VPC endpoint that's used to communicate with Amazon Managed Blockchain from the VPC. And that VPC endpoint can be used to restrict communication and users to access the service. And it's interesting to use a VPC endpoint because that's something that features a lot in the security policies of large and heavily regulated organizations. By using a VPC endpoint, you can restrict network traffic to only those entities within a VPC, your EC2 instances, lambdas, that sort of thing. And you can really close network access to the outside world, or you can only allow network access over your VPN or over your direct connect, or from other secure and trusted VPCs. So you have that ability to really control that network ingress and egress. And you can build on top of that by layering other AWS technologies. So for example, you want to build, say, a web application that builds on top of Amazon Managed Blockchain. You can layer other services to protect that against service attacks, web application firewalls, other resources. So you can layer on the gamut of AWS technologies and security services to build applications that use AMB effectively and overall strengthen your security posture.
Sounds good. Thank you for that. And similar, tell us a little bit more about availability. How can you build a highly available app leveraging AWS and Managed Blockchain?
So the design of AWS, it revolves around availability zones, as many people will be aware. Availability zones are one or more discrete data centers which operate on an independent fault domain than every other. And you can leverage multiple peer nodes across these different availability zones, such that your member will still remain functioning and participating within the network, even if there is a availability zone outage or some sort of fault within the local region. Giving you a substantial level of availability. And then you can, of course, build highly available apps on top of that have their own tenets of availability.
Great, thank you. I want to now quickly jump on to kind of our use case discussion. That has come up a lot of times. There's a lot of interest in from our audience who want to know what use cases are we seeing, what are customers doing in different areas. So Shruti, I want to specifically focus on that. I know from a business development perspective, you talk to a lot of our customers. Can you kind of summarize an overall a picture that you're seeing, and then probably take one or two favorite use cases and go deeper on them?
Sure. Yeah, absolutely. I did see questions around how is government using blockchain, how is healthcare using blockchain. Again, there you see it. I see the list there. So let's just start off with healthcare. Healthcare providers are using blockchain technology, specifically Amazon Managed Blockchain, in a ways where they can really manage the patient records to make sure certain doctors have access to certain patient records and not all of them. When there is a multiple hospital units, hospital locations, how is the access control managed, and how is the access control and the access of the data itself is audited for any kind of a compliance, regional, federal compliance to protect patients' data. That's one of the ways that healthcare is using blockchain. Healthcare is also using QODB to just track and trace all of the hospital equipment within the hospital system, so it's as a centralized database. So now going on to the government entities, multiple health government entities, this is the crux of where government and healthcare comes together, is government works with multiple universities, GSA organizations to track research data, whether it's mental health data, whether it's overall population data, trends data, and some government organizations such as FDA, for example, tracks multiple sources of data and works with universities and external organizations. And they are using blockchain networks to make sure that certain organizations have access to a certain point, and then the smart contract on top triggers off and cuts off data or gives data after a certain milestone has been reached. And same thing, the next step for this to overlay payments on top of this. Once an organization has completed their research work on this data, they get certain grants or they become eligible for more grants or so on and so forth. This is a great use case where you see the government and healthcare sectors coming together. Agriculture data it's agriculture and supply chain. The next two use cases are very intermingled. We talked about the spinach use case. The payment overlay again comes in where there's a smart supply chain where the payments are made once the agricultural, whether it's spinach or animal agriculture product, moves from point A to point B and certain conditions are met. There's also use of other emerging technologies like IoT, AI, and ML within these paradigms. Financial services market, it's something that we've seen pretty much being very quick early adopter of blockchain technology. We've seen there's clearing and settlement use cases for financial transactions from multiple exchanges. Singapore Exchange is one of our customers that started a project called Project Ubin. It's a multi-phase journey. Singapore Exchange is a big stock exchange business conglomerate in Singapore, and they're working with the Monetary Authority of Singapore, which is a government entity, and about 16 other banks and the industry to explore how to use blockchain for clearing and settlements of payments and securities. So up to this phase, using Amazon Managed Blockchain, they have completed the domestic delivery versus payment. So essentially they started with capital raising and capital trading for their customers. They have implemented post-trading technology, and once the post-trading technology is complete, now the settlement and clearing for domestic transactions are being done using blockchain. They plan to do international or cross-border payment, settlement, and clearing after this stage. So these are some of the use cases, and then again, they fall in the wheelhouse of three big important buckets. And as you can see in this particular slide, it would take more than 48 hours to settle any transaction. So while it's settled for the end customer, Singapore Exchange had to go back and do this on their side. It took 48 hours of overnight fees applied. The new benefit is now they can scale these transactions literally near real time by adding new partners to this network. So there you go. And this is a really quick architecture diagram of how managed blockchain, which John Fritz was talking about earlier, of how the architecture looks like. They have multiple banks, multiple tiers, sometimes multiple lines of businesses within the same bank working together with the Monetary Authority of Singapore, and all of them have access to the same source of truth at all times. So there is no need for reconciliation.
Sounds great. Well, thanks for that, Shruti. And as you were saying earlier, these are just some of the use cases we had time to talk about. There are many, many more use cases. And somebody in the chat window was sharing like a housing use case as well. So just want to wrap up here. Next steps, where can folks get started?
You can go to the console, search for Managed Blockchain, and go launch a network. We also have a bunch of information on our website, which you can get to from the AWS landing page, and our documentation is there as well.
Fantastic. And the slides will be shared after with all the attendees, and you'll have the recording available as well. And we have links there for other video tutorials as well as blogs in the slides as well. So feel free to get started, and we are here to answer any questions.
Yeah. Thanks a lot.
Thank you, everyone.